All right, well, what are the rules for multiplying? All right, let's talk about multiplying radicals. In this case, we're starting out by multiplying um, binomial radicals. So we're going to multiply these two things together. Now, folks, this is an awful lot like FOIL. Yep. In fact, I love using boxes because people's information gets organized and they don't lose things. I know some of you hate it. You would rather just draw 7 times 7 is 49. 7 times that is 7 radical 5, negative 7 radical 5, and negative 25. If you want to do that with arrows, I don't care. It's okay. Do it your way. But showing you my way, I put a box underneath and then I match things up, right? Very similar to what we did last semester with polynomials, where we match up the columns and the rows and so forth. So the one thing about the bottom right corner that I want you to remember is that really the bottom right corner is negative square root 25. The negative is not inside the radical, it's outside. And the square root of 25, we know that's 5. That's why I put negative 5 in the box. Now, to add those things together, and I probably didn't do that anywhere, so let's do that now. We've got 49. We've got 7 radical 5. We've got negative 7 radical 5. And we've got negative 5. Well, of course those two things cancel. And we only have left is 44, right? 49 take away 5. Now, you can also just do this. Makes my life a little bit more easy. And now some of the other ones are not as obvious, so that's why I wrote it out the other way, with like terms together, such as in this next example, okay? 8 minus 6 radical 7 times 9 plus 2 radical 7. Of course, I like to do my box, but if you don't want to, you can draw arrows. It's okay. But 9 times 8, oops, freeze that. 9 times 8 is 72. 2 radical 7 times 8 is 16 radical 7. In the bottom left corner, I've got my negative 63 radical 7. Wait a second. There's a mistake. Pause this video, because I'm wrong. I hate it when I'm wrong. Why isn't it pausing? As you can see, I fixed my mistake with the red number. Hold on a brief moment. Okay, so we're going to be adding the like terms together now. Obviously, the 72 and the negative 84. Where did the negative 84 come from? Well, when you multiply the radical parts together, you get negative 12 radical 49, which is really negative 12 times 7, which is negative 84. That's why I put that in the box. So when you add 72 and negative 84 together, obviously we get negative 14. And when we add 16 radical 7 and the correct negative 54 radical 7, we end up with what? Negative 44, take away 6, negative, or positive, negative. Why did I do that? It's negative, seriously, negative 38 radical 7. Okay, as your final answer. Okay, moving on. Where's my, I hate it when my controls do. Okay, so example 7, I've got a lot of practice problems here just to show you some more that you can look at for help. Let me just verify it quickly that I didn't screw it up like I did the last one. 4 times 6, 24, good. 4 times 4 radical 7 is 16 radical 7, good. Negative 6 radical 7 times 6 is negative 36 radical 7. And then in the last box, negative 24 radical 49, which is negative 24 times 7. And negative 24 times 7 is negative 168. So I can add the 24 and the negative 168. And that's going to give me a negative 144. And I can add the 16 radical 7 and the negative 36 radical 7 and give me negative 20 radical 7. So that's your final answer on this question. Okay, I know we're just, kind of beating into the ground this practice, practice, practice. When you want to square something, you're multiplying it times itself, so I wrote it out twice. And then I use my box method once again. If you just want to draw arrows and connect things up, that's fine, but you need to understand what you're doing. I get kids that try to think that they're doing things like, oh, square the 2, square the radical 3, and I'm done. No, that's misusing the multiplication property. That's the power of a power for multiplication. That is not what we're talking about here when we're multiplying binomials together. So if I were you, I would write it out. Then choose your favorite method of doing it. So I've got 4, I've got 2 radical 3, I've got 2 radical 3, and I've got radical 9, which is 3. Okay, so we can, where's my green? Ugh. I've got my 7, and I've got my 4 radical 3. There we go. Done. Moving on up. Okay, multiply together. I got 64, 8 radical 11, negative 8 radical 11. Oh, you know what's going to happen there. Whoosh, gone. And then negative radical 121, which is negative 11. So really, all we're talking about is 64 minus 11. What is that, 53? That's my final answer on this one. Now, I want to recall that we're dealing with something called conjugates. That's why you don't that's when you have those situations where you end up with things canceling out. We had that before, didn't we? Somewhere back up here. Oh yeah, the first one. Exactly. They were conjugates. That's why it ended up being just 44 and nothing else. Okay, let's get back to... Okay, number 10. Rationalizing the denominator. Okay, this is a little bit, a little bit more involved, but this isn't too terribly involved. That conjugates idea is coming back. We want, first of all, the idea of rationalizing the denominator means that we do not want a radical in the bottom. Basically, it comes from a long time ago when we didn't have calculators. We didn't want to divide by a really long, nasty decimal. So, but it does help you understand how to write things in a different form, which can come in handy for the complex numbers. It's a little weird for this stuff, but it is, it does still help you kind of practice a lot of this multiplication stuff. Anyway, so the conjugate of radical 2 plus 1 is radical 2 minus 1. You see the first part stays the same, second part changes. All right, now when we do this, we have to do the same thing to the bottom that we did to the top. So you'll see I multiply the top and bottom by radical 2 minus 1. Well, the top's pretty easy because you're just distributing a 3, right? The bottom's where you're multiplying the conjugates together. And so you could see I did that kind of work over here and ended up, those things are going to cancel out like we've talked about before. And 2 minus 1 is 1. Well, anytime you divide by 1, that's nice because it's just the same thing. 3 radical 2 minus 3 is your final answer. Don't get caught up in shortcuts, and the denominator is not always going to be a 1, so don't get delusional on that one. All right, people are always trying to come up with shortcuts. I don't know. I'm just trying to help you learn the math. So the first part stays the same. The second part changes to the negative. And whatever you multiply the bottom by, you must do the same thing to the top, otherwise you change. Now, you're going to see that I did all of the multiplication. I worked out ahead of time, right? So then I can add things together. And let me just double check. Okay, that looks good. So 56 and 21, that adds up to 77. And then I've got negative 20, that's negative 29 radical 7. So this goes in the numerator, right? And just for argument's sake, so I can quickly do this, when we're multiplying the other ones from the denominator, the conjugates, of course, those are going to cancel out, right? And we have 64 minus 63. Are you kidding me? We end up with a 1 again? These kids are going to think it always ends up being a 1. Oh my goodness, that's ridiculous. Because then they're going to be like, oh, it's always a 1. It's not always a 1, okay? But it was in both of the examples I gave you. So don't get that in your mind that they're always going to be a 1. All right. If it was something other than 1, what would you need to do? You would probably, let's say that the problem had ended up having a 5. You might write it like that, and Math Excel might be okay with it. Another way you could write it would be 77 over 5 minus 29 radical 7 over 5. I'm not sure if Math Excel would make you split it up, but maybe they would allow you just to keep it together. I would hope so, but Math Excel kind of gets picky sometimes. Okay, that's enough for this Swyk. So you can get on to that and then move on to your assignment.